What is biomolecular simulation? How can this field, a mixture of biology and computer science, help to better study diseases like COVID-19 and eventually also help to develop new treatments against them? Those are the questions European scientists are trying to answer with a little help from powerful supercomputers. Like many other research institutes around Europe, this one in Barcelona is busy finding the weak points of SARS-CoV-2, that's the virus that causes COVID-19, to eventually develop efficient therapies or vaccines. Molecular biologists here are dealing with a wide range of unknown challenges.
How do we think the virus is going to keep evolving? How important is its infectiousness in animal species close to us going to be? To what extent can one of these species become a long-term virus reservoir? How can we find or help to find new drugs that tackle COVID-19? How can we contribute to develop more efficient vaccines?
Given the volume and complexity of the questions, researchers have turned to this supercomputer called MareNostrum. Its fourth version can perform 11,000 trillion operations per second. The high-performance computer has already helped hundreds of researchers working in different areas on subjects like climate change and gravitational waves. It's also now helping to support research on SARS-CoV-2.
We're able to help researchers describe their problems, their questions in a fluid, easy, sequential way. They can use all of the resources of the supercomputer working on tasks in parallel to get fast answers.
This scientific cooperation is being made possible thanks to a Centre of Excellence of Computational Biomolecular Research, where computer science, biology and biophysics teams work together to provide academia and industry with medical breakthroughs in therapies or vaccines. Integrative modelling and molecular simulations are already being used to study here in Stockholm, for instance, looking at the protein properties of different viruses in several infectious diseases.
We could not do what we do without computers. The computers enables us to see things that we could never see in an experiment otherwise. It enables us to see how small lipids diffuse around a protein. This is not a structure. They move all the time. And no other experimental methods would be able to see that.
A key aspect is accessibility. That's the effort to develop widely used and scalable software tools that can deliver accurate answers to researchers in the fastest way.
Scientific computing is a very difficult area. Scientists need to design complex algorithms to express the science in terms that computers can actually compute and give you answers. So we need to design complex algorithms, which makes the software applications powerful but very complex. So one of the challenges is to make these powerful applications very user-friendly.
So, will supercomputers ever help to design tomorrow's treatments or vaccines? Scientists at this European research project say it's just a matter of time.
Give this 5 or 10 years, I think in the future computers are going to be the main driving force to identifying new drugs when we need to find them in weeks or months' notice. We're not quite there yet, but the work that's happening all over Europe is gradually contributing to it.